love the chase and the hunt, and I set the pace when I'm running. I always take what I want and I always give it 100. Don't need a bank, no I'm funded. Play the game like it's nothing. I'm always thankful for something. Don't take for granted, stay humble. Now wake up.
Hello and welcome to another edition of our podcast, YOLO Talks, a podcast where we talk about any subject in life from mundane to deep philosophical questions. The episode today is a really special one, isn't it, Marta?
Yeah, definitely. Can't wait.
Yeah, because today we are hosting one of the most brilliant astronomers and minds of all times, Avi Loeb. How does that make you feel, Marta?
A bit anxious, but I'm very excited to have this conversation.
Same here. Avi Loeb is the head of the Galileo Project, founding director of Harvard-University's Black Hole Initiative, director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics, and the former chair of Astronomy Department at Harvard University. He chairs the advisory board for the Breakthrough Starshot project and is a former member of the President's Council of Advisors on Science and Technology and a former chair of the board on Physics and Astronomy of the National Academies. He is the best-selling author of Extraterrestrial, the first sign of intelligent life beyond Earth, and a co-author of the textbook Life in the Cosmos, both published in 2021. Avi is now located in Massachusetts, United States. Hello, Avi. How are you?
Thank you for having me. It's a great pleasure. You could have saved some time by referring to me as a farm boy.
Why is that?
Because I grew up on a farm, and my current thinking is pretty much shaped by my childhood, and we can get back to that.
Yeah, I know. I've read some of your books. That's good. So, first of all, I would like to express our immense gratitude for having someone so relevant as you in our program today. It is hard to describe how lucky we feel. To me, the fact that you have accepted this interview speaks volumes of the passion for what you do and about the quality of the human being behind. So, paraphrasing one famous quote from Oscar Wilde, we are in the gutter, but some of us are looking at the sky. You're definitely looking at the sky, aren't you?
Yes, I am. And I don't see any distinction between humans. All humans are equal in my mind because there might be a smarter kid on our cosmic block. So the small differences we usually focus on between humans are completely meaningless if you look at the big picture.
I see, but I mean, like, not everyone is so humble. So thank you very much.
I think before we start our conversation, I have one question to ask, because that would kind of redirect our conversation later on. Basically, the question is, what is the worst question one can ask you during a conversation like this?
The worst question is to
Yeah.
focus on what the social media says about things, some of the things I say. And I don't have any footprint on social media, and I don't really care how many likes I have on Twitter because it's not really the important issue. If you look at human history, there were many instances where the popular view was the wrong one. And the lesson from history is that we should be guided by evidence and collect data rather than try to appease the popular opinion. And that's what science is supposed to be about.
Yeah, that's right.
Unfortunately, if you look around in academia, what you find is that scientists very often are guided by other motivations. They want to get honors, awards, they want to be liked by their peers just because their peers are serving on committees that allocate funds, that allocate prizes, and therefore they often very much take the beaten path. And um, for me, it's the road that was not taken, in the words of Robert Frost, that make all the difference. And the one reason I do that, take the road that was not taken, is because there is a chance of finding some low-hanging fruit because nobody took that path and it may be available.
Yeah, that's very interesting what you're saying, because I have the same impression sometimes that many scientists are more focused on getting likes in social networks rather than finding the truth. Do you think is there any other subject apart from extraterrestrial life which seems a taboo in current academic that you think a scientist community is also avoiding?
Well, I think this is the most important subject that is being avoided, and I'll explain why. Um, First of all, it has huge implications for the future of humanity, for our aspirations in space. If we do find evidence for a more intelligent civilization out there, we might learn from them. It's sort of like looking over the shoulder of a classmate, for the answers to fundamental questions. But if we can save 1,000,000 years in the process, instead of figuring out the answers ourselves, you just look at the tumultuous history of humanity, and it's full of wrong steps, not paying attention to evidence, and being sort of cruel to other people, which is really not the right path. And if we, instead of focusing on the two-dimensional surface of this rock that we live on, that we call Earth, which is pretty much what politics is about, you just focus on what's going on this rock. If instead of that we explore the third dimension of space, which we know exists, we might find that there is someone else out there from whom we can learn. And we can get into the details of how to find out. I mean, in the past 70 years, we've been focusing on the wrong approach. We thought, oh, we just developed radio communication, so let's search for radio signals from those other civilizations. But that's a very narrow-minded point of view, because we had radio communication for about a century, and that's only one part in 100 million of the age of the Earth. And we already see that we are moving away from radio communication to fiber optics here on Earth, to laser communication in space. And moreover, it's possible that civilizations that predated us are not around anymore. They died. And the radio signals are, if they were sent 1 billion years ago, they are 1 billion light years away. They are far away. We can't really detect them. And it's just like trying to have a phone conversation with Wolfgang Amadeus Mozart. You will never be able, as many phone numbers that you dial, you will never catch Mozart, okay? Because he died. And but however, if you look more intelligently for the music notes that he wrote, you will figure out what he was about. And in much the same way, it makes more sense to search for equipment, for relics left behind from civilizations that might not be around anymore, because we sent out spacecraft that will exit the solar system, 5 of them. And other civilizations may have done that 1 billion years ago. There is no reason to think that Albert Einstein was the smartest scientist who lived since the Big Bang. There might be smarter scientists on an exoplanet, and the civilization that benefited from the wisdom of those scientists could have sent probes that within 1 billion years filled up the entire Milky Way galaxy, all the habitable zones around stars. These could be self-replicating probes like John von Neumann imagined in 1948. Within 1 billion years, even with chemical rockets, you can traverse the entire Milky Way galaxy, fill up the habitable zones. The question is, do we live in such a reality? And that is not a philosophical question. That is not a question that we should address with science fiction. That is a question that you should address with science. And it's really strange that the academic community has such resistance to being open-minded about trying to look for these things. The strange thing is the government in the US is now very interested in that. There was a report from the Director of National Intelligence, Avril Haines, to the US Congress a year ago. And in fact, I met Avril Haines at the green room of the Washington National Cathedral in November last year. And I asked her, what do you think these objects that you reported about, the unidentified aerial phenomena, what is your gut feeling? If they are not from adversaries, humans, and they are not natural, what do you think they are? And she said, I don't know. And she has a bachelor's degree in theoretical physics. So that's why it was a very interesting conversation with her. But my point is, the government is very much interested. Now the Congress established a new office in government. NASA is starting a study to look into funding research on this subject. I established the Galileo Project a year ago based on a few multi-billionaires who visited the porch of my home. They were inspired by my book, Extraterrestrial. They gave me a few $1,000,000, and now we have about 100 researchers as part of the project, 800 more who volunteer. But the point is, at the same time that the public is extremely interested, the government is extremely interested, academia is not. And I find that to be a betrayal of the duty of academia to basically uh, echo the interests of the public and address them with a scientific method. Very often on committees that allocate funds, scientists, mainstream scientists argue, they say, we shouldn't take any risks because we would waste taxpayers' money. Well, guess what? The taxpayers want us to study this subject, yet there is no funding for it.
Exactly. That's a shame. But I'm also surprised, really surprised about the fact that academic science nowadays is also focused on things that are even more weird, like the evidence of multiverse or things like that.
Yeah,
I don't understand either.
that's the other thing. So people say, "Oh yeah, the evidence is not extraordinary yet for the kind of objects that came from outside the solar system being technological." By the way, only over the past 5 years, astronomers discovered the first objects from outside the solar system that entered near the solar system and came near Earth. The first one was a meteor in 2014, and with my student, we showed that based on government data that was released just a few months ago. In fact, this meteor was tougher than all other meteors, 273 of them, in the same catalog of meteors. And moreover, it was moving faster than 95% of all the stars in the vicinity of the sun. So it was clearly unusual, an outlier. And then in 2017, there was the second interstellar object, Oumuamua,
Wow.
which also didn't look like a comet or an asteroid. That's what my book talks about.
Yeah.
So the first two interstellar objects are weird. And I say, well, let's get more evidence. So my point is, extraordinary evidence requires extraordinary funding. You can't just say there is no extraordinary evidence for this subject. And yet the government is talking about some objects. And I think the time is ripe. We have the instrumentation that allows us to address this subject scientifically. And it's just a shame that we are not getting within the mainstream to address it. At the same time, when people say, oh, this is, we take the conservative view, at the same time, the mainstream of theoretical physics talks about extra dimensions, the multiverse, string theory, to ideas to which there is no shred of evidence. In fact, people were talking about supersymmetry as being one of the foundations of string theory. It was called superstring theory. And people said, yeah, that's for sure correct, because it's very likely to be correct, because the parameter space makes a lot of sense. Then the Large Hadron Collider was funded at $10 billion. And one of the main objectives, aside from finding the Higgs boson, was to confirm supersymmetry in the natural range of parameters. It was not found.
Yeah.
And my point is, okay, you can convince yourself, you can be liked on social media for proposing supersymmetry. Everyone would say, yeah, supersymmetry is right. You will give awards and honors to people who suggested supersymmetry. You would say that the parameter space is natural. Therefore, we not only solve that, we can build string theory on top of that. We can also say that the dark matter is the lightest supersymmetric particle. You build all these castles. And for decades, people celebrated the idea. And everyone, by celebrated, I said, I mean, it's mainstream, that awards, funding, everything is going in that direction. And then you do the experiment and it's not there. Okay. So my point is, we can celebrate as much as we want, just like, the clergy, like the philosophers in the days of Galileo celebrated the idea that we are at the center of the universe. That flattered the ego of many people, but it wasn't correct. And if you were to ask those philosophers to design a space mission that would reach Mars, they would never get to the destination because they thought that Mars moves around the Earth. So reality is whatever it is. It's not a matter of how many likes it gets on Twitter. And the way for us to get to understand reality is by collecting evidence. And what I find strange in today's academia is that ideas like string theory, like extra dimensions, they are celebrated as part of the mainstream. And at the same time, something as mundane, as commonsensical as saying we are doing something, sending equipment to space on a planet that we call our home Earth, and now we know that tens of percent of all the sun-like stars have a planet the size of the Earth, roughly at the same separation. So our backyard is not really unusual. So you roll the dice of intelligent life tens of billions of times in the Milky Way galaxy alone. Why should we be unique and special? You just say, okay, I don't know the answer if we are unique or special. I don't want to have a prejudice. I just want to search for such equipment. So if we invested billions of dollars in the search for technological equipment from other civilizations, and it would take, let's say, decades from now, we would not find anything, then we would be exactly at the same point as the search for dark matter is right now as part
Yeah.
of the mainstream. So I say, how is it possible that the search for dark matter, supersymmetric particles, is mainstream, whereas the search for technological equipment from other civilizations is not?
Yeah, and I think that our lives, our future as mankind depends on the investment we do on that, because it's twofold, right? It's pretty clear that there must be some other civilizations out there, and then in relation to that, I didn't want to ask you in relation to that too much about Oumuamua, because I imagine you've had many questions on that, but that was the first interstellar object that we detected, and we didn't have any natural explanation for that. But also, we need to focus on getting out of these planets, because we know we have an expiry date for this Earth.
Right. There is an expiration date. The sun will heat up and boil off all the oceans on Earth within 1 billion years. Uh, but beyond that, we tend to think that everything is centered on us. If you open the newspaper, it's all about us.
True.
But the truth of the matter is, we arrived relatively late. The human species existed for the last few million years. Okay, that's one part in 10,000 of the age of the universe. And so we came relatively late to this cosmic play, and we are not at the center of the stage. That's another mistake that was made early on before Galileo, saying we are at the center of the universe. Everything moves around us. No, we are not at the center of the stage. We know that. And we came relatively late. The universe existed for 13.8 billion years before we came to the play. So how dare we even consider the possibility that the cosmic play is about us?
Yeah.
That's a lack of perspective. And the best way, to figure out what the play is about is to look for other actors, because they may have been around for longer. Just to give you an example, one day I see a person on the street. My wife tells me, this person is looking at our house for half an hour. Perhaps, is stalking you because now you're well known. People may come to your home. So I went out and asked this person, why are you spending so much time looking at our house? And he said, well, I used to live at this house 50 years ago as a kid. And and he said, well, in your backyard, my father buried a cat named Tiger. And I said, well, this name sounds familiar, because, in fact, I took him and showed him the tombstone that said Tiger on it. Now, when I saw that, and we've been living in this house for 15 years, so when I saw this tombstone saying Tiger, I was worried that there is a tiger buried underneath it. I didn't know what's underneath it. Turns out there must be a skeleton of a cat. Now, this guy knew what's underneath. So my point is, the lesson I learned from that is, that if you share space with someone else, it's possible that someone who lived in that space for longer than you did knows more about it. And that can be expanded to the interstellar space. If we find another civilization that predated us, they may have much bigger knowledge of what our environment is about, and we can learn from them.
So this is what the Galileo project is trying to do, right? I mean, like especially since the Oumuamua discovery, right? Can you explain a little bit quickly how the Galileo project is trying to detect this object? Or
Yeah. So there are three branches of the Galileo project. One is focusing on this meteor from 2014. We know that it came from outside the solar system, but it was tougher than iron, and it could be a spacecraft from another civilization. So the way to find out is by going to the landing site of this meteor. It exploded in the lower atmosphere about 100 miles off the coast of Papua New Guinea. And the fragments fell to the bottom of the ocean there, and it's about 1.7 kilometers deep. So we are planning an expedition to
Mhm.
scoop the ocean floor and analyze the composition of those fragments and see if it's an iron meteorite or maybe it's made of an alloy that nature doesn't make. And of course, um, if we end up finding some device that has buttons on it, I would
Mhm.
love to press one of these buttons. That
Mhm.
would be a thrill for me. Just think about finding uh, the 100th version of the iPhone. You know,
Mhm.
for an entrepreneur from Silicon Valley, that would be like the burning bush was for Moses. There
Exactly.
will be a sense of awe and sort of a religious reaction to a very advanced technological gadget that that will take us hundreds of years to develop ourselves. Um, but I'm not, that this is wishful thinking, and most likely we will find fragments. And then the key question is, what are they made of? And so that's one branch. And I have $500,000 in funding, but we are still raising another million to get it going.
Mhm.
And the second branch has to do with dating the next Oumuamua. As we mentioned, in 2017, there was this object that came close to Earth but didn't look like a comet,
Mhm.
didn't have cometary tail, but was pushed away from the sun by some mysterious force. And
Mhm.
moreover, it had an extreme shape, most likely flat, and various anomalies that I describe in my book, Extraterrestrial, didn't
Mhm.
look like an asteroid. So it was not the same as the familiar objects, the familiar rocks in the solar system,
Mhm.
and so just astronomers didn't get enough data to infer its nature, and so we are planning a space mission that will meet the next Oumuamua,
Mhm.
and it's sort of like a dating. You need first to select your date, and we have a dating app, which is the Vera Rubin Observatory in Chile,
Mhm.
that will start operations in a year and could find objects like Oumuamua every few months. And then most of the time we will swipe to the left. But every now and then we might decide to invest $1 billion to go after one of them that looks as weird as Oumuamua was. So
Mhm.
that's the second branch of the Galileo project. And it's a very expensive branch, more than $1 billion for a space mission. The expedition to Papua New Guinea is 1,000 times cheaper. And it's only 1.5 millions, and it will be the first time that humanity puts its hands on the material of an object from outside the solar system, the size of a basketball or so. And then the third branch of the Galileo project are these objects that the government talks about, the unidentified aerial phenomena. Most recently, the US Congress gave additional attributes to those. They said that some of them are transmedium, they move between water and air and space. So they appear to be changing media. And the government doesn't know what they are.
Mhm.
Obviously, if they were identified with adversaries, other nations, then the information about them would never be talked about publicly, because
Mhm.
that's a matter of national security.
Mhm.
And so the fact that there are discussions about exploring them further in the public domain implies that the government thinks that, based on the data that is mostly classified, that they are they represent capabilities beyond human technologies, and
Mhm.
they do not appear to be natural. But of course, the government is not a scientific organization, so, and the sky is not classified. It's
Mhm.
only government sensors that are classified. So within the Galileo project, we developed a suite of instruments that was already placed on the roof of the Harvard College Observatory, that will take a video of the sky in the infrared, optical, radio, and audio bands. And the data will be fed to an artificial intelligence computer system that will analyze it, identify objects, and distinguish, for example, natural objects like birds, bugs, meteors, from human-made objects like drones, airplanes, weather balloons, satellites.
Hmm.
And then the question is there something else? And
Hmm.
it's a fishing expedition. We are completely agnostic, but the fact that the government talks about something else makes us hope to figure out what this something else is,
Hmm.
with high resolution data, high quality data that will be open to the public. This is a scientific research program, and I
Hmm.
should tell you, my first concern was that someone from the government will knock on my front door and say, "Don't do that." But no, I mean, to me, it sounds like the government is unsure what it's all about, and that's exactly where scientists can come into play and help figure out. And what's the worst case scenario? That we will figure out that it's that all of these objects are either natural or human made. Well, even in that case, we helped the government, we helped the public in figuring out the mystery, and I think we served society. So there is no better satisfaction than helping society for a scientist.
Of course.
Instead of working on extra dimensions, you can
Mhm.
ask questions in academia. You can ask questions that are equivalent to how many angels can dance on the tip of a pin, and
Yeah.
then
Mhm.
uh, you demonstrate that you are smart. You can do it also. Then someone else will extend the question to extra dimensions and say, okay, now in 10 dimensions, how many angels can sit on the tip of a pin? And then you will write papers about it,
Mhm.
and they will be
And they give
reviewed. And
awards
someone would say,
and
wow,
awards.
this is very sophisticated. This mathematical gymnastics is really
Yeah.
impressive. And maybe we can even use that mathematical gymnastics in a completely different context, like quantum chromodynamics. Suddenly it turns out that there is a
Mm.
connection between the mathematics you developed
Yeah.
to the question of how many angels can dance on the tip of a pen. There is a connection of that to how nuclei, atomic nuclei are described, and someone will say, "You see, that justifies the discussion." And so, that's considered part of the mainstream, demonstrating that you are smart. And
Mm.
I say, no, actually, helping society figure a very fundamental question is more important.
Yeah, I'm really amazed at the projects that you are leading, and especially the last one that I was trying to get some information is the Starshot project. I think that's like science fiction to me. I don't know. I mean, how far are we from actually having that project real?
Um, yeah, so that's a long shot in a way because we are developing a completely new technology that is very challenging. So the idea is to launch a spacecraft that moves 1,000 times faster than existing spacecraft. So the existing method for propulsion is based on chemical propellants, rockets, and they are limited to reach a speed of tens of kilometers per second. And the reason is simple. There is this rocket equation that if a rocket moves forward by ejecting gas from its exhaust backwards, that's the same way that a jet airplane moves. I once went on a jet plane. The ride was 10
Mm-hmm.
hours long, so I had some time to do the calculation. And you calculate that indeed the amount of fuel that the jet burns in throwing gas backwards is exactly the amount needed to push it forward
Mm-hmm.
against friction with the air so that it reaches the destination. And so it's a very simple principle. You throw stuff backwards and you move forward. If you were to, for example, ice skate and
Mm-hmm.
you throw a ball one direction, then you will move, that will push you in the opposite direction. So that's exactly the principle, and that's how rockets operate. And the problem with the rocket equation uh, is that you carry the fuel with you. Okay, you carry
Mm-hmm.
the ball before you throw it on the ice ring. Before you throw it, you have to carry it. So as a result, you carry a lot of weight with you, and
Mm-hmm.
when you throw stuff backwards, you have to accelerate the fuel as well as the payload, not just the payload.
Mm-hmm.
And as a result, turns out that you cannot exceed the speed that is much greater than the speed by which you throw the stuff backwards. And
Mm-hmm.
you gain only logarithmically
Mm-hmm.
with the amount of fuel that you carry,
I see.
because you have to accelerate the fuel with you. So so basically you are limited to the speed that you throw the fuel backwards up to a logarithmic factor. And if you want to increase your speed, you need to carry exponentially more fuel. And that makes it completely impractical to reach speeds bigger than 30 kilometers per second or so, because the the sound speed of the gas that is being thrown backwards by chemical propellants is a few kilometers per second. So that ends up being a fundamental limitation.
I see.
That's called the tyranny of the rocket equation. And so then you ask yourself, okay, that's one part in 10,000 of the speed of light. And it will take us about 50,000 years to reach the nearest star. And 50,000 years is the time that elapsed since the first humans left Africa. So that's a long time. If you were to launch a spacecraft back then, it would reach Proxima Centauri, the nearest star, just now. It's a very long time to wait, and I don't have patience for that. So the question is, can we reach the nearest star in our lifetime? And that's the idea behind the Starshot initiative. And in order to do that, since the nearest star is 4 light years away, if you want to get there in 20 years, you need to launch a spacecraft at 20% the speed of light. And that's a factor of 1,000 bigger than the speeds I was talking about. So how do you do that? Well, to reach the speed of light, you better use light. And you better not carry the fuel with you. And so that's exactly the concept, that the idea is to push on a very lightweight sail, to push it with light, basically reflect light from a sail that is sort of like a mirror, and the reflection of the light pushes it forward, just like a sail being propelled by the wind. If you imagine a sailboat, it's the same principle, except instead of the wind being air molecules bouncing off the sail of a boat, here it's the particles of light that bounce off the light sail. And we designed the parameters of a system, about 100 gigawatt of a laser beam shining on a 1 gram or a few gram payload, could bring it to 20% the speed of light within a few minutes across a distance that is 5 times the distance to the moon. And so the idea is to deploy a light sail above the atmosphere and then shine a very powerful laser at it for a few minutes.
That's insane.
And then it will move like a bullet in the direction of the destination, the target.
But
And yeah, go ahead.
but the sail is going to have some kind of electronics or something to
Yeah.
take.
So the sail, yeah, exactly, will be equipped by a camera that perhaps will take a photograph. So if we get close to the habitable planet near Proxima Centauri, it could tell us whether there is life on it, or
Jesus.
or is it like a desert. But it takes 4 years for the signal to get back to us. The distance is huge. So there are very significant challenges in this in this project. One is to design the laser. We call it the photon engine. The second is to design the sail. And the third one is communication across such a vast distance.
Yeah.
But so we are making just the first baby steps right now.
Well,
I don't know if it will be practical, but it's something to. But I should say NASA is planning to use light sails to small satellites that will be deployed in the very near future. They would, of course, not reach anything like the speed of light, but it's a technology that will serve humanity, hopefully, in the near future.
sounds amazing.
And
I mean, sorry.
I just had a question, like more like practical one. So how do you actually build it? Like, do you prototype it? Do you use some softwares to like put some parameters and you try to predict how it will behave? Like, how does it work? Like the creation process, actually.
Both. So first, of course, we have some software trying to select the best parameters that will optimize the performance of the system for a given cost. But of course, it's all about demonstrating it in the laboratory. So the hardware is extremely important, and we have various teams trying to work on the experimental verification of various concepts. Yes.
That must be super exciting. And how many people approximately work on a project like that? Are we talking
So
like
there is
hundreds?
an advisory board that I chair, and that has about 2 dozen people on it.
Mm.
But then there are teams that are funded to develop the technologies associated with different parts of the project. And on that, I would say there are hundreds of members of those teams. But it's a slow process because it requires, I mean, there are many challenges, and it's not easy, to develop completely new technology overnight.
Mm. And we also talked quite a lot about the resistance from the scientific community towards maybe certain like operations or certain topics. But we also know that you are in touch with like younger minds, students and stuff. So how do you see kind of the future of your domain going? Because I can imagine they have a lot of energy and a lot of like excitement. Like, do you see the future quite bright?
Yeah, it all depends on who shapes the future, you see, because history depends on who writes it. and
Mm,
uh, of course, I'm trying to bring more innovation and open-mindedness into academia. It's not easy because in the context of my book, I had of over 1700 interviews over the past year and a half. I had about 40 filmmakers and producers interested. In fact, the Venice Film Festival just sent me an email today saying that there would be a special session where they will present short videos, that 23 of them inspired by my book, and select the winning one
mm,
this weekend. And they wanted me to participate
Wow.
remotely in that. And every day there are interesting things happening. And my life is quite interesting now. And on the porch of my home, I hosted maybe tens of very distinguished people during the pandemic that came over to speak with me. So there is a huge level of awareness and interest in this subject. But at the same time, I was also, there was a huge amount of pushback in the academic community, people attacking me personally for no good reason, because, what I'm trying to promote is getting more evidence and discussing it openly. And they say, no, we shouldn't discuss it. Oumuamua must be natural. And then you look at the papers that were written about explaining it as a natural object, and they all advocate something that we've never seen before. They talk about a dust bunny, a collection of
mm,
dust particles that are held together in a cloud that is 100 times less dense than air. And such a thing would never survive being heated by hundreds of degrees as it comes close to the sun. We've never seen anything like a very rarefied dust cloud. The idea was that
Isn't science behavior somehow like religion at some point?
yeah, I would say so.
mm,
The second suggestion was it's a hydrogen iceberg, and then we can't see the evaporation of hydrogen. And I showed that the hydrogen iceberg idea would not work because this frozen hydrogen would get evaporated very quickly along its journey. And the authors, the proposers of this idea, agreed to that. So then a third group came along and said it's a nitrogen iceberg chipped off the surface of a planet like Pluto. And everyone said, yeah, that's it. And then the problem is that, well, first, we've never seen a nitrogen iceberg. And they say, oh, no, it's not in the solar system, it's in other places. And then when we did the calculation,
Jesus.
the mass budget doesn't work out. There is not enough solid nitrogen available on all the exoplutos that would account for a population of chips
mm,
such that one of their members is Oumuamua. But at any event, there is this, I would say it's, as you say, it echoes religious insistence in the sense that it's not necessarily rational, it's opposing diversity of views. So people are very happy to say, oh, yeah,
mm,
inclusion, diversity, these are very important concepts. But when it comes to ideas, no way. And then you ask yourself, okay, so what's the process by which ideas are selected? Is it really based on evidence? You look around, you see extra dimensions. We don't have evidence for extra dimensions. You should look at supersymmetry. Why are these ideas so popular? Dark matter, lots of ideas about what dark matter is are popular. None of them is verified. We haven't found what the dark matter is. So it's definitely not evidence making some ideas more popular than others. And it's sort of, in some cases, it's sort of societal. It's just because a group of people decided that these are likely, or these are more, these ideas allow them to demonstrate their
Mhm.
intellectual gymnastics. They can do calculations. They say, oh yeah, that sounds natural. But these are very subjective criteria. We should be guided by evidence, and moreover, we should entertain other ideas, not just those that dominate the mainstream. And I say also this possibility that that we see objects different than what we expect from the familiar objects in the solar system. It's just like the experience of going to your backyard and finding objects that came from the street and they don't look like rocks. You can have a
Mhm.
tennis ball, you can have a beach ball. Why should we rule out those possibilities? Why should we say we need extraordinary evidence
Yeah.
to even consider them?
Mhm.
Why should we say nasty things about whoever discusses them? We should be open minded as much as we are to extra dimensions, as much as we are to supersymmetric particles. And moreover, the implications to humanity are
Hmm.
huge. So there is also a moral obligation for us to consider it, because, you know, it's just what Pascal said about discussing God. You can't just dismiss it because the implications are huge. So
Yeah.
you have to discuss it in the context of what will it mean if it turns out that the answer is different than you advocate for. And so I think it's really unfortunate that 4 centuries after Galileo's case, where he was put in house arrest, today he would have been cancelled on social media. 4 centuries
Mhm.
afterwards,
There's some progress.
we don't learn the most important lesson that on which science is founded, which
Yeah.
is promote diversity of interpretations, such that by seeking evidence you will find the correct one, rather
Hmm.
than based on prejudice, based on social popularity, advocate
But
one solution that looks like the most appealing, or ego uh, pleasant to you. And I should say the experts really like to demonstrate that whatever we see uh, can be explained by their past knowledge. That there is this tendency,
Mhm.
because their self-esteem is based on past knowledge. They get awards, recognition. So they would always, experts would always say, oh, we've been studying rocks in the sky, therefore anything that we see in the sky must be rocks. Okay, because that otherwise they may have missed something really fundamental, and they don't want to take risks. So that's a natural tendency, but it goes against innovation in science.
so, Marta, do you want to ask? Because
I
I don't want to bother you too much. I know you're a busy man, and we would like to know something about the person behind all of these great
Sure, please
ideas.
go ahead, ask me anything.
because I have like multiple questions, but I think I'm just gonna start with one. I mean, it's one thought I have while we talk about like the science is that I think probably awards and popularity is doing a disservice to humanity because it's kind of feeding the egos instead of actually allowing people to explore things. And listening to this conversation, like what's clear, I think, for both of us is that you just have this hunger for innovation. You don't really care about like how popular you are. You just devoted to the topic. And I'm kind of wondering if you were like this from the beginning, or did you have any turning points in your career, in your life, when you were like, okay, I don't like where this is all going, and I want to go a bit more like against the, let's say, the, I don't want to say a flock of sheep, but you know what I mean. So was there any point like this, or where you just always had this inside you?
Well, I always thought independently because I grew up on a farm. I was
Mm.
not a city person. I was not much into social interactions and more enjoying nature. And every morning now I jog at 5 a.m. To see the sunrise since the pandemic started. I really enjoy the company of ducks, rabbits,
Mm.
wild turkeys, birds. So nature is very appealing to me more than social approval. And that was true since my childhood. And also, I was interested in philosophy at a young age, but circumstances led me to be a professor of astrophysics and eventually the chair of the astronomy department at Harvard for 9 years. I was the longest serving chair. Now, up till 2020, I was chair of the astronomy department. I was director of the Black Hole Initiative, founding director. I was director of the Institute for Theory and Computation. I was chair of the board on Physics and Astronomy of the National Academies. And I was also chair of the Starshot initiative. All of these leadership positions at the same time. I'm not talking one after the other, at the same time. And it gave me a broad perspective of how, science projects are done, how the community handles innovation. And I always felt that, that it's not following the correct guiding principles. But when both my parents passed away a few years ago, and that, as far as I'm concerned, that was a big moment because it clarified to me that we live a short time, and we better focus on substance. And It's sort of like the phrase that was mentioned in the famous film "Gone with the Wind." Frankly, my dear, I don't give a damn. That was sort of what I thought, um, and I just want to really focus on what matters. And I told my wife, look, this subject of searching for extraterrestrials uh, through physical objects, not by looking for radio signals, which we did for 70 years, we didn't find anything. And also Enrico Fermi back in 1950 asked the question, where is everybody? Well, that's not the right question. You can sit at your home and say, I don't have a neighbors because I don't hear anyone knocking on my door or sitting next to me from the street. But that's not the right way to find them. You need to look through your windows and better use a telescope. And so he didn't use telescopes, and now we do have them. And of course, it's a self-fulfilling prophecy not to search and to argue that there is nothing out there, that there is no extraordinary evidence, because we are not searching, there is no evidence. And so to me, it sounded like one of these subjects that was improperly treated, and and it should be addressed using the scientific method. And as a result of Oumuamua, I was driven into it. So it was not completely out of the blue. It was Oumuamua that brought me to the recognition that, here is the first reported object from outside the solar system. It looks weird, so maybe we're missing something. In 1920, it was thought that the sun is made of the same material as the Earth. Okay, and then came along Cecilia Payne-Kapashkin and did the first PhD in astronomy at Harvard University and Radcliffe. And she argued, based on data, that the sun is mostly made of hydrogen, not of the rock that we find here on Earth. And Henry Norris Russell, the director of the Princeton University Observatory, very distinguished at the time, said, that is impossible. He said to her, we all know that the sun is made of the same material as the Earth. Please remove this statement from your PhD thesis. And she was a beginning astronomer, a woman, and said, okay, well, if you say that, I will take it out. And otherwise she would not pass the exam. And so she took it out. And then, just to show that she was wrong, for the next 4 years, he collected new data and analyzed it, and then realized that she was right. So he wrote a paper about it saying, yes, the sun is made of hydrogen. And the strange thing is, a few decades ago, there was a visiting committee to Princeton University Department of Astrophysical Sciences. And the chair of the department was bragging, saying, we have a very fine tradition. 80 years ago, the director of the Princeton University Observatory, Henry Norris Russell, discovered that the sun is made mostly of hydrogen. And fortunately, on that committee was one of my colleagues at Harvard, and he corrected him and said, no, the actual story is that he made the wrong statement. It was Cecilia Payne-Kapashkin who discovered it. Just to show you that history depends on who writes it. But this was the first step. The second step was for people to realize in 1933, Fritz Zwicky, an astronomer from Caltech, figured out that groups of galaxies, clusters of galaxies, contain much more matter than you can associate with ordinary matter, with stars, with gas. And he
Dark
called
matter.
it dark matter. 1933, for 40 years, the astronomy community dismissed that. It was
Yeah.
unpopular, ridiculed, and then it started to gain traction because more and more evidence came to justify it. And of course, now if you ask any postdoc student, they would say, of course, there is dark matter, no doubt about it. What, are you crazy that to think that
Yeah.
there is no dark? But if you go back to the first 40 years, it was exactly the opposite, just to
Yeah.
show you how history goes. And
Okay.
so the lesson from that is most of the matter in the universe is not what you find in the solar system. Just like we found that most of the matter in the sun is not what we find on Earth, most of the matter in the universe isn't, like I'm saying by most, I mean 80%, is not
Yeah.
what we find in the solar system. Here again, then comes the third part of this story, which is interstellar objects. You would say, oh, they must be like the rocks we see in the solar system, the familiar rocks. But
Mm.
Oumuamua comes along, it has different properties. So this is, I see it as the third step of the universe telling us, look, what you find in your vicinity is not necessarily representative of what's out there. It
Mm.
was the sun is made mostly of hydrogen, the rest of the universe is made mostly of hydrogen in terms of ordinary matter. And then most of the matter in the universe is dark matter, not what you find in the solar system. And then interstellar objects are not the objects that you find in the solar system. So why should we do again the same cycle of resisting the idea, pushing back, just like against Zwicky, against Cecilia Penko-Pashkin,
Mm.
pushing back against it, ridiculing it, and then wasting 40 years in the process? And I'm
Mm.
saying, let's collect evidence. Now, of course, if you ridicule it, you will never collect evidence. Therefore, you will never correct yourself.
Mm.
So
I
true.
want to ask you another personal question. Like a man like you that has been trying to defend the scientific method and has faced some backlash from your colleagues or whatever. I mean, what is the main lesson that you have learned in life, and what would be the best lesson that you would want to pass to your daughters?
Yeah. So, what I learned, and I was sort of fortunate to develop that, because I see other people that are my age. I'm 60 years old. I see other people, they have white hair, they have a lot of scars on their face. I was fortunate, I still jog for half an hour every morning. I run faster than a lot of young people. I still enjoy. And why is that? Why am I able to behave sort of like a kid? It's because I isolated myself from social media. What I
Yeah.
tell young people is, you go to the beach, and what you find there is that there are seashells that were just swept ashore. They have their unique colors. But then, if they spend a lot of time on the shore, the waves uh, bring them again, rub them against each other, and they start breaking up and losing their color. And they end up as indistinguishable grains of sand. And that's why, if you keep rubbing against other people on social media, on anything, you will lose your unique colors,
Mm.
and you will become indistinguishable dust grain. Now, of course, it gives you a good feeling in the sense that you are no different, and nobody would attack you because you are just like all the other dust grains, all the other grains of sand on the beach. But the question is, what's the point, of
Yeah.
living through life? I think it's much more beautiful to see, those seashells of different colors and shapes. And so what I would advise young people is to keep their colors, their unique colors and
That's a great
shapes.
advice.
And the way I was able to do that is, first of all, not subscribing to social media, not paying too much attention to what other people say, and at the same time maintaining my childhood curiosity. And I really refuse to surrender to external pressure. Now, the only reason I'm able to do that now is because I have a senior appointment. I had leadership positions, so people are not attacking me, because there is this tendency when you see a flower coming above the grass level, there is a tendency of people to step on it so that
True.
it will not look different from the grass level. And the way I avoid that is because I established myself. I don't depend on those people. There were so many attacks when my book came out that if I were a postdoc or a student, I will stop practicing. And in fact, a number of junior faculty came to me. There was a 60th birthday celebration, a conference in Martha's Vineyard, where 70 of my colleagues, former students, postdocs, and senior people came to celebrate my birthday. And some of the junior faculty came to me and said, we see what's going on in academia. We are very distressed, and we're thinking of leaving academia because it's not what we hoped for in terms of an environment that would encourage innovation and good ideas. This environment is rewarding for other things, and that was very distressing to me to see that. And I try to encourage them to stay within academia and change it. But I'm fortunate enough to have a secure position and a status that allows me to do what I'm doing. And I should tell you that some of the most aggressive attackers a year or two ago were people who didn't publish a scientific paper in the last dozen years, 10 to 15 years. These are people who comment about science, didn't write a single scientific paper that they published, yet they had a lot of negative things to say about my scientific research, which is published in peer-reviewed journals. And I ask you, how is it possible that these people get so much attention and they are sort of prominent on social media and their opinions get a lot of likes? These are unqualified people. They don't practice science. And in the old days, before social media, they would get no traction because back then it was your actual scientific output that matters as to gauge your. But nowadays, if someone says negative things and others people want to step on any flower that goes above the grass level, they would embrace that. It's sort of like an attack dog. You want an attack dog that will, even if the attack dog just has teeth but no other qualifications, you send the attack dogs and the attack dogs bites. And that's what you enjoy and upload. And that is a phenomenon that exists right now, that there are all these attack dogs that do not really have qualifications, but people send them and they cheer them and they like them. And fortunately, I don't have any footprint on social media, so their bite is very minimal. I don't even check any bite that they have on that platform.
It's a huge burden. This all reminds me to last movie I watched, Don't Look Up. John, I don't know if you've watched it, but
Yes, I did see it. Yes.
yeah. Anyways,
And there were some true phenomena there. I mean, the superficiality of the response of political figures to science, where it's seen as either helping or damaging them politically. That's the way that they look at it. But also the way that colleagues and the way that the public attends to science is really not substantive. And it's unfortunate because one reason I search for intelligence in space is because I don't often find it here on Earth.
That's fair, actually. That's fair. Okay, I think we are almost at 1 hour. I have one short question, and I think we'll finish. So, my last question is: what would you say each of us will do tomorrow if you had like one kind of advice for all of us?
I think you should think about what is your passion. What are the questions that are most inspiring for you, and try to follow those because we now have the luxury that for example, the a cave dweller didn't have. Cave dweller had to hunt, had to worry about survival, and we often forget, but we can get our groceries for relatively low cost, and then dedicate most of our lives to other concerns. And so you just need to find what is your passion, and then guide your life accordingly. Now, it's not always true that there is a job that will pay for what your passion is, but if not, then you find sort of a compromise. Now, in my personal case, I was driven into physics and astrophysics. That was not my passion. My passion was philosophy, But I said, given the circumstances, given all the constraints that I have to serve in the military and I served for 8 years, given those constraints, I would like to do some intellectual activity that is the closest you can get to philosophy. So I said physics is something that, that was recognized as contributing to the defense of the country. So I was allowed to do that, and it was the closest I could get. And then one thing led to another, and I ended up with an offer for a faculty position at Harvard in astrophysics. And then I realized that even though it was an arranged marriage, I'm actually married to my true love, because I can address philosophical questions using the scientific method. And that makes me different than many of my colleagues. And so what I'm trying to say is that sometimes life puts constraints and doesn't allow you to go along the straight path to what you really want to do, but you will find your way and actually shape your path that is constrained in that direction. And that could give you a very special perspective about what you actually do that other people that do it do not have. So that was my experience. And I say, life is constraining, but first you need to define what your passion is and navigate and try to pursue it, no matter the obstacles that life puts on it.
That was brilliant. That's such a good way to phrase that. Thanks a lot.
Thanks a lot for having us here. Yeah, I mean, like we could be talking to you like all evening, but thank you so much for being with us, and I hope one day we can talk to you again with some proofs of whatever we are talking about, so that at
Finding a
least
passion.
in our life in our lifespan we can find conclusive proof of life in other planets, or even So thank you very much.
I look forward to that. And let's speak again in a year.
Yeah. Oh well,
Sounds
that's
good. Maybe
hopefully.
face to face one
I'm
day.
optimistic. I do think that in the coming years we'll have interesting evidence. And my wife always says, if they ever come to get you and they land in our backyard, I just want you to do two things. She says, make sure that you leave the car keys with me, and ask them not to ruin the loan when they take off.
Perfect.
Yeah, there is intelligence here on Earth.
Oh yeah, clear planning strategy is ready.
Yeah.
Amazing.
Okay, thanks again, Avi.
Thank you for
Take
having me.
care.
Yeah. Have a nice
Bye-bye.
day. It was a
You too.
pleasure. That was awesome. Such an
Yeah, it
interesting
was.
guy. I learned so
It
many new
was.
things. I love his stories as well. Like the way, like his
Yeah.
storytelling is amazing. Like the story about the tiger cat as a
Yeah.
metaphor, and also the show's amazing. Yeah, how do you feel?
I feel like the time has flown by. I mean, I would have spent like 4 hours with this man talking about.
Yeah.
I mean, there are many subjects I couldn't touch because the amount of time. But really impressed that we have had the chance to talk to someone leading so many important projects for humanity. But I'm shocked. But I mean,
Same.
I I'm really like he's really confident that in his life span he's gonna he's gonna do important things, and that's, I mean, I wouldn't like to die without knowing whether there are other civilizations out there, or whether we can really go to other stars with and try to see exoplanets. I mean, I would like that to happen. What about you?
Yeah, I think the key interesting things, well, everything was interesting, but the things that kind of stuck with me are that that's so true, and it's not only with science that people are being criticized for having different opinions, or even trying to have a different opinion. I think it's such a shame that young people, for example, are discouraged from even entering the field because it's so kind of, I don't want to say full of haters, but you know what I mean. It's just that it's very hard. And another thing he mentioned is that this childlike curiosity, and also maybe just trying to either remove the social media, or maybe put the amount of usage to quite low, so you can actually focus on yourself more, and developing yourself, and maybe not paying attention to what other people think, or maybe what's popular, what's not popular. Yeah, because I think it does a massive disservice, I think, to people, like as individuals, but we got a really good example that is also the disservice to science, like where money could be put in something very important, whereas put somewhere else, or maybe it's already kind of disagreed with even before it starts. So yeah, I think it
Yeah.
was super interesting, especially coming from a person who, is like on the top of his field, and
Yeah.
such a interesting, humble guy.
I think there are many interesting aspects here, like for instance, the role of social networks in general, not only in science. I think
Mm,
it's very hard for people to stand out, and to
mm,
look for the truth when all we do all day is, try to be like the rest,
mm-hmm.
through social networks, and try
Yeah.
to sell an image, sometimes forgetting about the real truth of our lives, and even science, which is scary. And also the other thing that I was thinking all the time is like, why is considering the existence of life in other planets something so hard for us? Is it
Mm,
because science movies, the version of extraterrestrials that we have been sold in those movies,
mm-hmm.
or is it because people have just accepted the fact that we are never gonna enter in contact with other civilization, or even we are never gonna be able to travel to other planets, and it's like the existence of life, we just go on with our lives and we don't want to even think about it, and that is also embedded in some scientists,
Mm-hmm.
unconsciously. What do you think?
Yeah, I think it could be, yeah, a combination maybe of fear, and also that it's so far-fetched that maybe it's not worth putting much investment into, because it might never happen that we discover something. But yeah, I'm just one thought I had when you were talking about it as well. And I really don't want to
Mm,
shit on education, but when I start thinking about how, I was learning things, like it was always that you have to fit into a certain kind of key of answers. Like there was not much space for you to develop your own opinions. Like that's
mm,
something that I learned later with life. And I think there's already a shame that it's being sort of like put to sleep. It's not killed, but it's put to sleep at such an early stage. Maybe if that wasn't the case, of course, it being subjective, maybe other countries or schools have a better kind of way of teaching. But I think we should cultivate this curiosity and maybe boldness, and as we talked during this conversation, just being curious, and being a little bit out there with your opinions, probably might hurt a little bit, but I guess it's more worth it in the end, because you are here for like a fraction of second
yeah,
of a human life. So yeah, I think there's a lot of, I think it's a lot of lessons from a very intelligent person that lived their life in a very like meaningful way. And some of it of course applies to science, but a lot of it just applies to life. And that's why I think this conversation was like multi-dimensional, and we can all learn so much from that.
true. I absolutely agree. I think the conversation was life inspiring, to be honest. And yeah, I mean, like, there are many thoughts in my mind right now. But yeah, I mean, like,
Another
I'm
podcast.
another podcast. But yeah, it's funny. And just the last comment that I'm gonna say, it's just funny how history repeats over and over itself, like
Yeah.
from Galileo Galilei to modern times. Like it's so hard for us to. Sometimes we think we are so advanced, we are so intelligent, but we are so dumb that for
Mm,
us to go forward, it takes lots of effort, right? So it's just
yeah. But I
amazing.
think we're blinded by egos. I
Yeah,
think we are intelligent. It's
true.
just like, I think the ego is the problem. And that's why we
But
talked about the awards and popularity. I think it harms a lot of people. Like, I think you need to
yeah,
be very mentally strong. It also applies like to like athletes and actors and everyone. So you remember how it was at the beginning. So you were doing it because you're passionate about it, not for awards or recognition and stuff. I think that's hard because a lot of people kind of get lost in the the likes or money or whatever, and they kind of are scared to do something else because they already have a position that is secure, and going
yeah,
out there with maybe, I don't know, controversial opinion or controversial book or whatever, it's kind of risking it. But we had a pleasure to talk a person who didn't give a damn about it.
yeah.
So yeah.
He even doubts about our intelligence, and
Yeah.
I think he's right, because like what you just mentioned, the ego. I mean, it does ego a sign of intelligence. It's a sign of intelligence that we know have climate change in front of us, and we are still spoiling the planet. It's a sign of intelligence that we are not investing real money in trying to colonize other planets before it's too late. Or I don't think we are that intelligent. So at least is something to argue about. But anyway,
That's a question for
that's the
today.
question.
Are we
Yeah,
intelligent or?
yeah. Maybe for another podcast. And on
I
that
see a
note,
topic already,
yeah,
or
on
at
that
least
note,
three different topics.
yeah.
But on that note, sorry.
No, I just want to say that we've reached the end of our program. It has been a pleasure to share this evening with you and obviously with Avi. And
Yes.
I hope our listeners also enjoy it. And we'll talk in our next podcast. We'll see who is invited or what we will talk about. So thank
Yes.
you very much and see you, Marta.
And we say hi to our moms who are listening to that, and
Hi,
three
mom.
other people who maybe will be listening to that.
The problem is my mom doesn't understand English, but
Same for mine, but they will listen.
yeah. Hi, mom.
Hi, mom.
Goodbye to our listeners.
Play the game like
Goodbye.
it's nothing. I'm always thankful for something. Don't take for granted. Stay humble. Now wake up. It's time to look at the enemy. Look in the mirror if he is no friend to me. It's not working out. Maybe it's the chemistry.